Hello everyone, welcome to a new clip in the C# for Beginners playlist where we will discuss enumerations. But to better understand why would you use something like this, let's try to understand what the issue is and how do they solve it. So imagine you are building a game and the player must choose a difficulty level, and the level must be one value between three predefined options: easy, medium and hard. So you would have something like this, where you have a method called startGame that takes a string as a parameter, and then that string representing the difficulty of the game. Then we do some decisions based on the value that is provided for the parameter, like if the difficulty is easy, do that; if it's medium, do the other that, and so on. We could have used the switch just as well. Now what happens if by mistake I spell the provided value all lowercase letter like this? Obviously, this is a bug, because if you remember, lowercase e and uppercase e are not the same character, so this check will fail. Or what if I misspell it? Or even worse, what if I choose an option that is not even valid? And you can see how this problem is non-solvable, because this is a string. This accepts any kind of text. No matter how much I try to protect myself against this kind of issues, I can't. The solution to all this is quite simple. We create an enum that contains only the options that we need, like this. As you can see, we use the C# keyword enum to declare the enum, then we give it a name, and then in the body delimited by the opening and closing curly brackets, we specify the options that we need separated by comma. Now this becomes a C# data type, just like a class or a struct, so we can use it, for example, to declare variables like this. And notice that when I say difficulty level dot, I have hard, medium and easy, the options that we specified, and these are the only options that I can choose from, and they are spelled correctly for me, so I can choose one. And now obviously I'm calling this method with a difficulty level type, but it's expecting a string, so I need to also update the method itself to take a difficulty level as a parameter. And compare that parameter against the difficulty level option, in this case easy. Not only does this read a lot better, but the greatest advantage is the restrictioning you just saw of only offering a predefined set of values that makes it explicit of what is acceptable in the current context. And this is compile time check, so if you don't choose one of the predefined values offered here, you won't even be able to compile and run your program. You should also know that the options of an enum are stored behind the curtains using integers, so if I hover them with the mouse, you can see that it says equals to 0, 1, 2, and so on. And I can even give them values manually like this. And now they start from 4 and it's 5, 6, and so forth. But you have to understand that this doesn't mean that they are actually integers, so this won't work, because difficulty level is of type difficulty level enum, not an int, so you cannot just compare it against an int like that, because it is not an int, even if it is stored as an int behind the curtains. However, you can manually do an explicit cast like this, and this would work. Note that most enums have a first member called none to signal an invalid value, and this is recommended to be placed as the first member so you don't break the ordering later on or have to manually assign numbers to them to keep them sequential and so on. Just imagine how weird it would be to have an enum that says easy, medium, none, hard, and so on. One last thing about enums that you might find a tad more advanced, but it may be helpful to you one day, is the fact that we can combine multiple values of an enum to form a new enum value like this. And the first thing to notice is the values are now powers of 2. That's because behind the scenes, the values are stored as bits, and powers of 2 occupy different bits. So we can combine them, and the bits of those values, those combined values, would not overlap. At some point I will make an advanced version of this video where I go in depth about how that works, and if I won't forget, the link of that clip will be in the description below. The all option at the bottom is where we combine multiple values using the bitwise OR operator. So all literally means up or down or left or right, so all directions. And then in your code you could do stuff like this. So the hasFlag method checks if a particular option is present in the combination we have. And this could be useful, for example, is in permissions, settings, whatever, where you have multiple values and they are active at the same time. Speaking of flags, you may notice this attribute on some of the enums that you will encounter. And I know we haven't talked about attributes yet, but ignore that for now. Some developers will mistakenly state that this is what enables you to combine members on enums like this. But that's misleading, because you can combine them just fine without it, and its purpose are actually two. One of them is to modify the toString method when you print some of the members of the enum. So for example, if I write all.toString, then if I don't have flags, it will print the numerical value of the all member that it holds behind the scenes. When I place flags, it actually prints the components that make it up, down, left, right. So that's much nicer to read. The second effect is to signal to other developers that this enum is intended to have combined members like this. So this is explicit now, that it's not a mistake, it's by design. At the end, don't forget some of the mistakes that people usually do when it comes to enums. Like for example, not placing none as the first element in the enum to signal an invalid option, not using powers of 2 when they use enums as flags to combine multiple options into a new one, or not using an else or a default case in case of switches to actually check the members that could not be part of an enum. Because for example, some user could cast any int to your enum type, and even though it's not an invalid value, it still compiles, so it will not be covered by your cases. That was it for today, and as you can see, it's not that complicated, but it's not entirely simple either. But you do have to agree, they do serve their purpose. In the next lesson, we will talk about a new chapter in software engineering, which is data structures, and I do believe you will enjoy that one quite a lot, because if we were to use just arrays, our programming lives would be a constant pain. So if you don't want to miss those clips, maybe you should subscribe, and if this clip helped you in any way, don't forget to also click the like button. For now, I bid you a kind farewell, and until next time, thanks for watching, and I'll see you in the next tech frame.